You just opened an app, typed in a city, and watched a plane ticket appear in seconds. 12 hours from now, you could be on the other side of the planet. You didn't think twice about it. But the real answer to how humans first crossed this planet is far stranger, far slower, and far more dangerous than anything you've ever booked online. Your ancestors didn't have maps, they didn't have compasses, they didn't even have boats for most of their journey. And yet, within roughly 70,000 years, small bands of humans walked, paddled, and drifted their way from a single region in East Africa to nearly every corner of the earth. No other animal has ever spread this far, this fast, without wings. So how did they do it? Start with the walking. Around 70,000 years ago, small groups of Homo sapiens began leaving Africa in waves, not a single dramatic exodus, just families, maybe a few dozen people at a time, following food, following herds, following rivers. Anthropologist Chris Stringer, who has spent decades studying human origins at the Natural History Museum in London, describes this less like a planned migration and more like a slow leak. People didn't set out to conquer continents, they just kept walking toward the next valley, the next coastline, the next patch of green. And that's the part your brain struggles to imagine. There was no destination. No one alive at the time knew that Asia existed. No one knew Europe was out there, colder and stranger than anything they'd seen. They were simply pushing into the unknown, one generation at a time, because staying put often meant starving. Here's where it gets strange. Genetic research led by Rebecca Cann and Alan Wilson in the late 1980s traced human mitochondrial DNA back to a single common female ancestor nicknamed Mitochondrial Eve, who lived in Africa roughly 150,000 to 200,000 years ago. That doesn't mean she was the only woman alive. It means her maternal line is the one that survived unbroken in every human on Earth today. Every person you have ever met carries a thread that traces back to her. Think about that. Your DNA is a travel journal. It records every migration, every crossing, every near extinction your ancestors survived, whether they knew it or not. Now picture the coastlines. For a long time, scientists assumed humans spread across land, following herds of animals across open plains. But that theory has a problem. It doesn't explain how humans reached Australia by around 65,000 years ago. Australia has never been connected to Asia by land. Even at the lower sea levels of the Ice Age, there was open water to cross. Deep, current-filled, shark-infested open water. So, how did they get there? Archaeologist Jon Erlandson has spent much of his career studying what's now called the coastal migration theory. The idea is simple but radical. Instead of only moving inland, some early humans followed coastlines, using the ocean itself as a highway. Coastlines offered fish, shellfish, seaweed, and fresh water all in one place. You didn't need to hunt a mammoth. You just needed to walk along the shore and pick up dinner with your hands. To reach Australia, though, walking wasn't enough. At some point, someone built a raft, or a canoe, or lashed logs together with vines out of desperation or curiosity, or both. No blueprint survived, no written record exists, but the archaeological evidence is undeniable. Humans were in Australia tens of thousands of years before anyone else on Earth attempted an open ocean crossing like it. Pause on that for a second. Somewhere on a beach in what is now Southeast Asia, a small group of people looked out at the horizon, saw nothing but water, and decided to go anyway. That single decision changed everything. Meanwhile, in the north, a different kind of journey was unfolding. Around 20,000 years ago, during the peak of the last ice age, so much of Earth's water was locked into glaciers that sea levels dropped dramatically. A strip of land connecting Siberia and Alaska, now called Beringia, opened up. Not a bridge exactly, a vast grassy plain, sometimes hundreds of miles wide, teeming with mammoths, bison, and horses. For a long time, textbooks taught that humans simply walked across Beringia and then down an ice-free corridor through Canada to populate the Americas. But newer genetic and archaeological research has complicated that story. Geneticist Jennifer Raff, who studies ancient DNA from indigenous populations across the Americas, has helped show that the ice-free corridor likely wasn't passable early enough to explain the earliest human sites in the Americas. Some of those sites date back over 15,000 years, possibly older. So many researchers now believe the first Americans didn't walk south through the ice. They paddled, hugging the Pacific coastline in small boats, moving from kelp forest to kelp forest, island to island, the way their ancestors once moved along the shores of Asia. The same coastal survival skills that got humans to Australia may have gotten them into the Americas too. Here's the part that should genuinely unsettle you. These crossings happened repeatedly on opposite sides of the planet, thousands of years apart, without any of the groups knowing the others existed. Humans kept independently arriving at the same answer. Follow the coast, trust the water, go anyway. Why would anyone do this? Why would you load your children into a small boat and paddle toward an empty horizon? Because staying still was also a gamble. A drought could end a group in a single bad season. A resource-rich valley today might be barren in 10 years. Movement wasn't reckless. It was often the safer bet. Your ancestors who stayed comfortable and unmoving didn't always survive to pass on their genes. The ones who kept adapting, kept exploring, kept crossing into uncertain territory, those are the ones whose DNA you're carrying right now. That restlessness didn't disappear. It's still in you. Think about the last time you felt an unexplainable pull to see somewhere new, a city you'd never visited, a trail you'd never hiked. Psychologists call part of this novelty-seeking behavior, and it's been linked to variations in dopamine receptor genes, including one called DRD4, which some researchers have connected to exploratory personality traits across human populations. Not everyone carries the same version, but the underlying drive, the itch to see what's over the next hill, is written into the species. By the time humans reached the southern tip of South America, roughly 14,000 years ago, they had completed one of the most improbable journeys in the history of life on Earth. Starting from a single region in Africa, on foot, in small boats, without maps, without writing, without knowing what they'd find, they had reached nearly every livable landmass on the planet. No planning committee organized this. No leader charted the route. It happened through thousands of small local decisions made by ordinary people trying to survive generation after generation until the entire globe had been walked, paddled, and settled. So, the next time you book a flight and the map on your screen draws a clean, confident line from one city to another, remember what that line is actually built on. It's built on people who had no line to follow at all. People who looked at an empty horizon and decided the unknown was worth the risk. You didn't inherit that decision. You inherited the outcome. And somewhere in you, the pull to keep going is still awake, waiting for the next unexplainable moment when you look at a map or a horizon or a plane ticket and feel the same ancient urge your ancestors felt standing on a beach thousands of years ago, staring at the water and deciding to go anyway.